Hey, engineering students, I'm going to take on the circuit design challenge. You hopefully have done this already and figured out a way to do this, complete this challenge. I'm going to do two different solutions. You may find that you have a different solution than either of my two solutions, and that's perfectly normal because there's more than one way to do this. I'm going to be doing this on the Tinkercad simulation. So I've got a battery pack off to the side here. You can't really see it, most of it. It's about 6 volts. The exact voltage doesn't matter too much. And I'm going to hook up, I already have this hooked up to positive and negative rails. Actually, I have them backwards, so I'm going to change this. Positive rail is there. I need to undo that. There. And negative rail is at the top. It didn't matter very much, but I didn't want to get confused. Okay, I'm going to put 3 switches on here. And the switches I'm going to use are different than your switches. You use push button switches, but I can't push more than one button at a time in this simulation. So I'm going to use a slider switch. These slider switches, I can turn them on and then go to the next switch and leave them in the condition that I set them at. How these slider switches work, there's 3 terminals here. The middle terminal is connected to either of the side terminals depending on the switch position. So I'm going to use the right side to be on and the middle to be like my connection to positive voltage. So that's the next thing I'm going to do. And I'm going to run a wire from the positive rail to the middle terminal and make it red because this is positive for all 3 of these switches. So now I've got my +5 wired into the one side of the switch. The other side of the switch is going to go to a resistor. So how I'm going to do that is I'm going to take my resistor, this is a 1000 ohm resistor, and jump it across the ditch from the output terminal from my switch. I will do the same thing with the other 2 resistors on the other 2 switches. Jump them up a little higher. Okay, so now the path of current could be from +5 through my switch, through a resistor. And now I'm going to tie all these resistors to one common location to put them in parallel with each other. So I'm going to hook a wire up from here to, I'm going to say this spot over here. And then I'm going to hook a second wire from the output of the second switch to that same location. I'm going to make this a different color just to keep it clear. And then from the third switch, I'm also going to go to that same location. And again, different color. Now from that location, I'm going to go through my LED. I'm just going to run a wire from that common location to another spot just to give myself a little more room to work with. And then I'm going to install my LED. Just change the color of this maybe to purple. So here's my LED. Now the cathode, that's the positive, the negative side, is on the left, on my right. The long side, that's the positive side. That's on my left. So I'm going to pop this in place so that the positive lead, that anode lead, is attached to my purple wire. And then I just have to complete the circuit by going to ground. So I'm going to attach a wire from here to the ground rail of my breadboard, and I'm going to make that black because I'm going back to ground. Okay, so what I have now is 3 switches in parallel with each other, and then they're each in series with a 1000 ohm resistor. So watch what happens when I run this simulation. When I switch on one switch, the light glows. Here's what's going on. This is the circuit right now. Current is going through my first switch, through the 1000 ohm resistor, over to here, jumping through my purple wire, running through my LED, and then go back to ground. The total resistance in my circuit is just 1000 ohms, because this is just a very simple switch, resistor, LED, ground circuit. resistance is 1,000 ohms. Okay, watch what happens to the brightness of the light when I switch on the second switch. You can see that it got a little bit brighter. Well, here's why. Now I have two resistors in parallel with each other, because current can split at this positive rail and now can go through switch 1 and through its resistor, and switch 2 and through its resistor. But because they're in parallel, that means the total resistance is 500 ohms, because 1 over the total resistance is 1 over 1,000 plus 1 over 1,000, which is 2 over 1,000. So the total resistance is 1,000 over 2, which is 500 ohms. 500 ohms is less resistance than 1,000, so more current is going through the LED, so it's brighter. Now I'm going to switch on my third switch, and the LED gets even brighter. Now I have 3 resistors in parallel with each other. So my total resistance is 1 over 1,000 plus 1 over 1,000 plus 1 over 1,000. That's not the total resistance. That's 1 over the total resistance. So that means the total resistance is 1,000 over 3. So now that my resistance has dropped from 500 down to 333 ohms. Less resistance, even more current goes through the LED. Now let's hook this up a different way. Okay, so I've cleared off my breadboard and I'm ready to start building a second solution that relies on a series kind of a strategy to give myself 3 different LED lightings with 3 different switch settings. Let's go back to the breadboard. So the first thing I'm going to do is I'm going to install one switch, and I'm going to put it about maybe here, and I'm going to attach the input to the switch to the positive. So I'm going to use that red for that. The output to this switch is going to be a resistor. So I'm going to take one of my 1,000 ohm resistors and I'm going to jump it across the ditch. The output for this resistor is going to go to a second resistor. So I'm going to go back across the ditch to here, and then I'm going to take another resistor and jump across the ditch from there. And then the output for this is going to go to a third resistor. So maybe you go to there, jump the ditch with my third resistor, and then the output for the third resistor is going to go to my LED. So I'm going to go to there, and I'm going to make a little jump over to here, install my LED anode side to the left because that's the positive end, and then I'm going to connect the base, the cathode, to my ground, and I'm going to show that in black. Okay, with this one switch in place, you can see what's going to happen here. I open this switch, current will go through all 3 resistors, so that's a total resistance of 3,000 ohms because they're in series, so you sum up their resistances to get the total resistance, and then the light will light. Now I'm going to take this second switch and I'm going to install it so that the input is on the same connection as the input to the second resistor. And then the output for this switch, I'm going to take this and I'm going to jump it over to the front of the third resistor. So now if I turn on both of these 2 switches, current will flow through the first 1,000 ohm resistor, but it'll jump over the second 1,000 ohm resistor because instead of going through this high resistance pathway, it'll just go through this wire and go through the second or the third resistor. And so now my resistance has dropped from 3,000 ohms to 2,000 ohms because it's only going through 2 of the resistors. Now I'm going to take this third switch and I'm going to pop it in there. And then I'm going to take a wire and I'm going to run that wire over to where my LED connects. I'm going to change this color to blue just to kind of keep things a little bit clearer. And I'm going to change this other one to orange. Okay, so now if the first switch is closed and the second switch is closed, current will flow through the first resistor, but it won't go through the second resistor. Instead, it'll go to the head of the third resistor. But if this switch is closed, the third switch is closed, it's not going to go through the third resistor either. It's going to go just through the blue wire and then straight to the LED and to ground. So that drops the total resistance from 2,000 down to 1,000. So with one switch closed, I have 3,000 ohms. With two switches, it's 2,000 ohms, so that's even brighter because it's less resistance. And with 3,000 ohms, it's brightest of all because the resistance drops to a third of the original value. Let's start the simulation and see if that's true. Turn on one switch, the LED lights, 3,000 ohms resistance. Second switch, it's brighter, 2,000 ohms resistance. Third switch, it's even brighter because I've dropped to 1,000 ohm resistance. It might be easier to visualize this if I draw the circuit. So I'm going to try to do that. I think it might be a good idea to stop the simulation first. So first I'm going to draw my battery. And I have a switch. That's the first switch that I put on the board. After that switch is a resistor. After that resistor is another resistor. After that resistor is another resistor. And then I have my LED. And then from the LED I go back to ground. Now, parallel to the second resistor, I put another switch. That's the second switch. And parallel to the third resistor, I put another switch. That's the third switch. So, with this switch closed, current flows through here, that's 1,000 ohms, here, 2,000 ohms, and then this one, that's 3,000 ohms total, and then through the LED. If this is closed and this one is closed also, current flows through the first resistor, but it's going to bypass the second resistor and then go through the third, so that's 1,000 plus another 1,000, 2,000 ohms. If all three are closed, current will flow through the first resistor, bypass the second, bypass the third, and then your total resistance drops down to just 1,000 ohms, and that's why it was the brightest.